and welcome to another quick math tutorial. Today I'll be showing you how to do simultaneous equations. So here I have two quite simple simultaneous equations that we're going to solve. And in this example I've made it so that one of our terms, which is y, in one of the equations y is positive and one is negative. Most importantly, they have the same coefficient but just reversed in sign. So that will be 1 and negative 1. That's important because if we add them, they cancel out. You get 0 in the end. So what we're going to do is we're going to add both equations together. Essentially all the terms are going to be added together and the y should be cancelled out, and we should be left with some amount of x is equal to some number. And doing that we can solve x, and then we can solve later for y. So if I add both of these equations together, we're going to get a 7 amount of x, and we're going to get that as equal to 28. Now, if we divide by 7, what we'll get is x is equal to 4. Now we know x is 4. We're going to substitute 4 into one of the equations whenever we see an x. So, for example, I'm going to put that into the blue one here. And we're going to say that 3 times 4, which is 12, take away y, is 4. So if 12 takes something as 4, and if we rearrange that, well, you can work out from 7 that y would have to be 8 for that to work, and that would work for the other equation too. Okay, if I move on to another example. We have here 3x plus 2y is 30 and 2x plus 2y is 28. In this case we can't add them anymore because no terms will cancel out by that. What we can do is take them because we have two like terms, which again is y. It's 2y in this case. So what we're going to do, I'm going to do the red equation because it's bigger, there's more terms. Take away the blue equation. So we're going to take sign there. And what that leaves us with, x is equal to, as the y's cancel out, 2. Because 30 take 28 is 2. And we're left with just one x term, which is nice because we don't have to cancel that out. Where you get the answer for x. And we're just going to put that back in. And I'll put it into the red one this time, and we get 3 times 2, that is 6, plus 2y is 30. I'm going to write that. If I take 6, we get 2y is equal to 24. When we divide both sides by 2, we get y is equal to 12. And that's both our values got. So I've got one more example for you guys. Just the final one, we've added, but there's still one thing that we haven't done yet, and that is actually time from terms. Because if if you times every term by something in an equation, it's still true. It's still true. Everything's got now been times by 2 or whatever you've done. And sometimes we don't have any like terms to begin with. So we have x plus 2y is 14, 3x plus 4y is 22. What I'm going to do is I'm going to times our red equation all by 2. Because that will get us 2x plus 4y is 28. And now we have 4y, which the blue equation also has. And then we can do what we did before and take 1. And I'm going to do the red take the 1. So I'm going to do the red equation times 2, hit the blue equation. So remember, we've doubled everything here. And that would get us 2 lots of x minus 3 lots of x, which actually is a negative x. The y's will cancel out. We'll put this is all equal to, then we'll have 28 take 22, and that is 6. So we have minus x is equal to 6. Now we can just swap the signs around here to get the answer, which is basically dividing by minus 1. Minus x divided by minus 1 is positive x. minus 6 divided by minus 1 is negative 6. So x is equal to 6 minus 6. There we go. We're going to sub that back in. It's probably best not to, because later it gets a lot more complicated. We're going to sub it into our one of our original equations, so not one of them doubled. We'll sub it into the blue one. And we'll get 3 times 6, which is 18, plus 4y is 22. Let's write that. 18 plus 4y is equal to 22. Take 18 from both sides. Left with 4y is equal to 4. And as you can see, we can divide both sides by 4 and get y is equal to 1. So we have minus 6 and 1. So I hope you enjoyed that video, and yes, in the next video I will explain how to do quadratic simultaneous equations, because yes, you can have x squared and y squared in this. It's a little bit trickier, but I'll be showing you a new method which is a lot easier to solve them to. So thanks for watching, and please let me know in the comments what you thought about this video.